Okay, so let me do this question. This is a part of the first half of your set of 10 standard strategy questions. Now, I think this question might be simple enough that I don't need to use a standard strategy. So let me just doodle as I go. It says a team of 9 members each engage in a tug of war, pulling in opposite directions on a horizontal rope. So let me just have this as a kind of representation of the rope. Each of the first team's members has an average mass of, oh wait, do I need to draw? Interesting. Let me start by drawing free body diagrams of the things being mentioned. I have a team 1, and there's gonna be some mass of team 1. The total mass of team 1 will be the average mass times the total number of people, 9. Just doodling as I go. And I'm given the average mass, 68 kilograms, and exerts an average force of 1340 Newton horizontally on the ground. So the ground will be, I'm imagining like pulling, I'm pushing the ground, I guess, kind of. So let me imagine this is a team on the left, so team 1 on the left, team 2 on the right. So team 1 must be pushing the ground to the right to give themselves a leftward force. So there's a leftward kind of reaction force. And as a reminder to myself, this should really be the average force that they are giving us times the total number of people, 9, I think. Average force of 1340 Newton horizontally on the ground as they pull on the rope. Each of the second team's members has an average mass of, okay, let me draw the second free body diagram. So free body diagrams. Second team, mass of the second team should be the average mass of the second team times 9 again, because each has 9 people. And I'm given the average mass, 73 kilograms. That doesn't seem fair. They are not evenly matched. And exerts an average force of 1350 Newton horizontally on the ground. If I'm on team 2, I'm pushing the ground to the right so that I can left, to the left so that I can have a rightward force. Yeah. So there would be a rightward the reaction force 2, and this will be an average force, right? So this will also be F average 2 times 9, average 1 times 9, as they pull on the rope in opposite direction. Yeah. So if I'm looking at forces on team 1 and team 2, there are internal forces that are not being mentioned here. So there should be some force on team 1 by team 2, and there should be some force on team 2 by team 1. But it looks like they are, they are asking for the tension force. Okay, so I'll need to figure it out. I think I can go in order. So for part A, where it asks what is the magnitude of the acceleration of the two teams, I don't need these internal forces quite yet, because for this purpose, I'm justified in treating the whole thing as a system. So I can imagine having a free body diagram of the system as a whole. That thing will have a total mass, that's the m1 plus m2, and the vertical forces, let me ignore them, it's not going to be interesting. Really, the forces that are the net external force on this system comes from the ground. There's the reaction force from the ground, 1, and there's a reaction force from the ground. So looks like the rightward force will be greater. So let me do it this way. So I'll do rightward force, 1350 Newton times 9 total, minus the leftward reaction force, 1340 Newton times 9. That's the net force. If the question asked for net force, I would give this. It asked for acceleration, so I need to divide this by the total mass, m1 plus m2. So that'll look like the average mass of the first team. Or let me do in order, since I did the second team first, since they're the winning team, I think. 78. Are they the winning team? No, they are the winning team. So 78 kilogram times 9 plus 68 kilogram times 9. So this should give me the net force divided by total mass, the acceleration, hopefully. Wait. Newton per, yeah, that's mass times. Oh, wait. Newton per gram. Oh, yeah, I don't know why. Let me just say in meters per second squared. I don't know why it didn't just give me that right away from the beginning. 0.0685 meter per second squared. So 0.0685. I recommend always keep three significant figures. I think you could have rounded this to 2 and maybe it'll have worked, but three significant figures. Now, why does it say it's wrong? I spotted my mistake, which is here. I put in 78 kilograms when it should have been 73 kilograms. So with that, I should have correct number. So with that, I get 0.7092, so 0.709 meter per second squared. Now that should be right. Yeah, sorry, there were so many questions with the errors. Otherwise, I would have looked harder for this mistake that I made. So that's part A. For part A, you just need to find the acceleration. You don't need to know these internal forces. Now, here's a kind of the fun thing you can do now that you know the acceleration. So with some reasonable assumption that the rope is not stretching, that means you know the acceleration of these two teams. So you can say that I think I figured out the team 2 should be winning, so it's accelerating to the right. They are both accelerating to the right with the amount of acceleration that we figured out. So we can use either of the pictures, either the picture for the team 1 or team 2. Let me use team 1 because that's the earlier drawn thing. It's higher up. So we can write down Newton's second law equation and see that that gives us enough information to figure out this internal force. So let me write down Newton's second law equation. For team 1, I can say that net force, let me write down the internal force first, since it's going in the same direction as acceleration. F12 minus the F reaction, the outside force, is equal to mass 1, the total mass here, times the acceleration. And this is an equation with everything known except for this internal force. I know everything else, so I can solve it for that internal force. F12 is equal to M1A plus F reaction 1, and I can just plug in these numbers, get the force that way. So let me actually keep this. I think I can keep this and use it for my acceleration, and I'll have M1, that's the 68 kilogram times 9 times the acceleration plus the net force, that's 1340 Newton times 9. There's probably a way I could have simplified it, but you know, for simple, for one question like this, although simplification work, it feels to me like it'll cost me more time than simply plugging in numbers. So the tension ought to be 12,103 Newton, and that should be slightly greater than this 1340 times 9. So 12,103, and you don't have to round it at all either. There's some judicious call to be made. I think when you are using Wolfram Alpha, often it'll give you numbers in a way where it doesn't give you 10 significant figures or 10 figures when only 4 or 5 of those are significant. Now, why is it saying it's wrong? Okay, so having checked the question code and everything, it coded in a wrong answer. I'll file an errata with the question author. This is the correct answer because it's not asking for the net force on the team 1 or net force on team 2. It's asking for the tension force. So if whichever team you use, you have to work with the expression for the net force that includes the reaction force from ground and the tension force. And I think one thing you can figure it out is, so using this approach, whether you use team 1 or team 2, let me actually do team 2 so that I can show kind of as a consistency check. So, net force on team 2, it's going to be, so to the right, so let me start with the F reaction 2 minus F21 is equal to M2A. So F21 is equal to F reaction 2 minus M2A. And when you do this calculation, you'll find that that gives you the same magnitude as this one, as you should expect from Newton's third law. So if I did, wait, that looks wrong. So that's the, oh wait, that was correct for before. For so I want to start out with the reaction force on team 2. So that would be 1350 times 9, and then this time minus their mass 73 kilogram, not 78, times 9, and the acceleration is the same. So when you do this, the answer you get is the same as what I got before using team 1. It doesn't matter if you use team 1 or team 2. And again, it's asking for tension force. So I'll file the errata. This is the correct answer. And the approach you see here, it's the correct approach. Don't let the X mark mislead you. Yeah, it's this answer that's wrong.